All right, so now we're on section 2.4 from the other book. So this is the handout specifically for just this section, and it's on inequalities with absolute value and quadratic functions. So I've drawn some pictures here, and so these are graphical interpretations of equations and inequalities. So what we're going to do is we're going to let f and g be some function, okay? Now in our case, we're letting the g basically be a linear function and the f be a quadratic function. But it doesn't matter what the functions are, they can be anything. Okay, so if we have the solutions to f of x equal to g of x, where is that going to be? Well, that's going to be all x values where the graphs of y equals f of x and y equals g of x intersect. So if we look here, first one's a case where they intersect. It comes down here like this, and the only solutions are those points right there. Okay, and so that's when f of x is actually equal to that g of x. Now the solution to f of x less than g of x is a set of x values where the graph of y equals f of x is below the graph of y equals g of x. So where's that? Well, again, we have the same graph, so we can just think about that. And so where is f of x less than g of x? Well, that's g of x. So anything for the other one that's less than that, so below, is going to be where it is. And so on this line here and on this line here. So basically, starting at that point, going all the way to positive infinity, and starting at that point and going all the way to negative infinity. Now, it equals that point only if this is equals. Now, it doesn't equal that point if it's not equal to. So you're going to have to use, the parentheses for, less than or greater than, and a bracket if it's less than or equal to or greater than or equal to. Okay. Now, where's the solution for f of x greater than g of x? Well, again, it's going to be the graph where, or the looking at the graph where it's above, where the f of x is above our g of x. And so that's just from this point to this point. And so, we have to go to our axes here, and it's going to be, from one point to here. So whatever that point is, and that point is on x, and we'll write that into our little parentheses notation, and that's going to be the solution for where f of x is greater than g of x. All right, so this is going to be an actual example where we have to draw it out and simplify and see where those values are. All right, so going back to what we learned about how to graph these items, this is a quadratic, and it's going to be shifted down by 2. So if we start here, maybe say that's where the 2 is. It's going to go up, and it's going to go up. So something like that. Now this one, how's it going to look? Well, it's going to be reflected over. So basically, instead of coming up like that from 0, it's going to come down, but then it's shifted up 2. So we're going to go up 2, and then we're going to come down like that. So they should be the same on both sides, but they're obviously not quite the same. And if I mess it up, probably is what's going to happen, make it even worse. But it's going to come down something like that. So they're supposed to be basically mirror images of each other. Okay. Now, we want to know, one, when is f of x equal to g of x? Okay, well, let's write that down over here. Well, they're equal at the points right here where they're crossing. Well, let me draw circles here. So it's going to be equal right there, and it's going to be equal right there. Okay. Now, how do we know what those points are? Well, those points are going to be when either of the graphs are crossing the x-axis. And so whenever x is equal to 0. So if we think about that, well, we just set each of those, whichever one we want. If we set this equal to 0, we get x squared equals 2. If we set this equal to 0, we get x squared equals 2. So in either case, we're going to get the same thing. So x squared minus 2 equals 0. So x squared equals 2. Now we take the square root of both sides, but when we take the square root of that number, it's going to be plus or minus. So x is going to be plus or minus the square root of 2. So we're going to have then on this one, the point is going to be a minus square root of 2 comma 0. And on this one, it's going to be a plus square root of 2 comma 0. Okay. Now we probably better label which one is which. So this one is this, so this is our f of x, this is our g of x. And so they're equal when? Well, at that point there, they're equal at negative square root of 2. Maybe we put the negative up here. So we can call that that. And 0. And then and positive square root of 2 comma 0. So those 2 points only. Now, when is f of x less than g of x? Well, f of x is this one. When is it less than g of x? Well, it's less than down here. So maybe let's let's change a highlighter. And so it's less than in that region there. And so we'll just kind of highlight that so we know what it is. And so 2, well, that one is going to be less than from a negative 2, square root of 2, all the way up to the positive square root of 2. So if we do that, it's going to be from negative square root of 2 to positive square root of 2 over that interval. Okay, so these are just points, and that's over the interval. So these are 2 points, point 1, point 2, and this is an interval. Okay. Now, when is f of x greater than g of x? Well, now we want it to be above, so that's going to be those 2 going up there. So let's change to a different color. Oh, I don't know, let's do green maybe up here. And so we want the green highlighter and make it that one. And so when we go up here and up here, that's when f of x is greater than 0. Okay. So when is that? Well, that's going to be from basically this point down or this point up. So we're going to go from negative infinity up to that negative square root of 2. And then we're going to say in union with, and now we're going to go from the square root of 2 up to positive infinity. So we have 2 pieces. It's going to be here or here, okay? All right. So yeah, so that's basically what we've done. We had to first graph them both. Then we had to kind of find these points because those are kind of the intersection points, and so that gives us this one. But it also is the switching point where it's going to go from either less than to greater than, and so we needed it for that. So we set one of the equations equal to 0, solve for x. That gave us those 2 points, and then from there we could get our intervals. And then again, this is intervals. Okay. All right. So that's how I would solve that. Well, now let's go look here. So solving inequalities with absolute values. What are we going to do? Well, if we let c be a real number, then we have the following options. We can have c greater than 0. And if that's the case, if the absolute value of x is less than c, then we can rewrite it in the form x is greater than a negative c and x is less than c. So when that is the case, we can write this. Now, here again, we have that, but now it's less than or equal to. Well, the only difference is we switch that less than to less than or equal to in both cases. And these are our and. So it has to be x is greater than negative c and x is less than c. And so we're going to get some, interval here. And this one will have an interval here, but it's going to be with brackets. Now, what if c is less than or equal to 0? Okay, well, if c is less than or equal to 0, then if we take the absolute value of that, we can't have an absolute value be negative, and so there's no solution. Okay, and the same thing works for c just strictly less than 0. We can't have that, and so there's no solution there as well. And I think maybe this is probably supposed to be greater than less than, and that's not supposed to be there, but that's okay. So basically, no matter what, we can't have absolute value less than c. It doesn't matter if it's less than or equal to or just strictly less than. Now, if c is greater than or equal to 0, and here we just had strictly greater than, now it's greater than or equal to on both of these, then what do we do? Well, here absolute value is going to be greater than c or greater than equal to c, okay? And in both cases, what happens is it's just the difference of the greater or less than or equal to. it's going to be x is less than a negative c, so we're going to say it's going to be negative and negative, or x is going to be greater than c. Okay, so we're going to have or. So these are the two ors, these are the two ands. So when we have less than c, then that's going to be the case, but when it's greater than, then we're going to get that or option. And then our final one, c less than 0, and then absolute value is greater than c. Basically, that means every number we plug in there is going to be true. So all real numbers. Okay, so the nice options we're going to get are this one or this one, because we don't have to do any work. We just automatically say either no solution or all real numbers. The others, we actually have to simplify, solve, and then figure out what our actual intervals are. All right, so let's do that with this one. So what we have is absolute value of 2 minus x, and then minus 4 greater than or equal to negative 3. Well, first we want to isolate the absolute value. So when we isolate it, we're going to add 4 to both sides. So 2 minus x absolute value is going to be greater than or equal to what? 1. Okay. All right, so we have greater than a number. And so what we're going to do is, if we remember back, that's going to be greater than a number. We're going to have the or, okay? And so what we're going to say is, we're going to convert the absolute value to 2 minus x is going to be greater than or equal to 1, or 2 minus x is going to be less than or equal to a negative 1, all right? Now we solve both of those for x. And so we're going to have to take the x to the other side and then the number over here, or we can take the number over here and then divide, and then remember to switch our inequality around. It doesn't matter what you do, whatever you're most comfortable with. So I'm doing everything in one step. So those cancel, and I have 2 minus 1 is 1, and then greater than or equal to, and x, the ones cancel. Or now again, I'm going to add x, add x. Now here I'm going to add 1, I'm going to add 1. So 3 is less than or equal to x. Okay. Now, what we can do is we can directly write out our intervals, but I find a lot of times it's best to go ahead and draw a number line, and then we can write our intervals from there, because somehow we always, our brain will look at it and say, oh, it's this, and we'll leave out a piece, or we won't write both pieces, or something's going to happen. And so I'm going to look, and I have a 1 and I have a 3. Doesn't matter how what the interval looks like. You know, we could put a 1 right here, put a 2. We could have spread them out more. It doesn't matter. We're just getting a general form of our notation. So here we start with x and we read to the number. So x is greater than or equal to 3. Well, that's going to be a closed circle and everything to the right. Here it says x is less than or equal to 1. So again, closed circle, but now we're going to the left. And now what I'm going to plot is what that is. Well, that's going to be from negative infinity to 1, bracket, union, bracket, 3 to positive infinity, parenthesis. And so that is going to represent what I have here. Now, if I could have just look here and say x is less than or equal to 1, and so, okay, well, that's what I get. And if I could look here and x is greater than or equal to 3 and write that, that's fine. But I think writing it out on the number line sometimes is more helpful. And that way you don't forget something in case you have maybe extra things, because sometimes you might have the or and then an and so then you're going to have to kind of combine things together, and that makes it a little more difficult. All right, what about on here? We'll do this one and then we'll take a break and come back with some extras. We're going to do the same thing, and what we have to do is we have to think about what this is. Well, we have this is greater than or equal to that, and this is less than 7. So we have an and. So let's break this apart. Let's say we have 2 less than or equal to the absolute value of 4 minus x, and then we can say over here, and absolute value of 4 minus x is less than 7. All right, so what do we do? Well, now we're just going to look at this and say, okay, well, this is going to give us an or statement because it's going to be greater than some number. So we'll have, if we want to write it this way, we're going to have 4 minus x is going to be less than or equal to a negative 2, or 4 minus x is going to be greater than or equal to a 2. So I just kind of moved this to the other side and rewrote it as absolute value of 4 minus x greater than or equal to a 2, and then I could kind of work with it this way. Now, does it help me? It really doesn't help me, because still I'm going to have to add x, add 2, add 2. So 6 is less than or equal to x. Here I'm going to add x, subtract 2, subtract 2. So 2 is greater than or equal to x. And so from this one, I've got two pieces again. So I've got a 2 somewhere, I've got a 6 somewhere. And so x is less than or equal to 2. So I have a closed circle going that way. And here x is greater than or equal to 6. So closed circle going that way. But I've still got and, okay? So this and is going to mean I'm going to have everything here and here to make it a true part of my solution. So with this being less than, that's going to convert me to an and statement also. So I'm going to say, well, that ends up being 4 minus x is going to be less than 7 and greater than a negative 7. Okay, so if we need to look at that, we're going to come back and we're going to end up with something like that. Okay. Now we just solve for x, but first I'm just going to subtract 4 all around. And I'm going to have to divide by negative 1 when I get done. So it looks like a negative 11 less than negative x less than 3. Now I divide by negative 1, divide by negative 1, divide by negative 1. Now I'm going to draw these arrows down to remind me to say, okay, now it was less than, now it's greater than, it was less than, now it's greater than. Well, negative divided by negative is positive, that's positive. Now this is negative. So now I'm going to say x is less than 11, but x is also greater than a negative 3. So now I'm going to have an 11 out here and some negative 3 way out here, and I'm going to have open circle all the way to the 11. So I'm going to have that kind of interval. Now it says I'm going to have this and this. So that means I have to have wherever the intersection of this bottom line and top line go. So if I do that, that means I'm going to have here, well, here I have open circle, here I have a closed, so it has to be a parenthesis, negative 3, comma, well, I'm going to go up to 2. Both of those are closed now, so that's a bracket, union. Both of these are closed, so it's a bracket, 6, comma. Now that's open, so it has to be a parenthesis and then 11, okay? And so this then gives me the solution set for this inequality with the absolute values. All right. So what we'll do is we'll come back and we'll start something with graphical.